webinar by Third Eye Consulting Services and Solutions. I am Paris Toshi, and I have with me DJ Das, who is the owner and founder of Third Eye Consulting Services. Just wanted to let you know that if you want to learn more about us, that you can visit thirdeyecss.com. You can also contact us as results@thirdeyecss.com. There's a Twitter handle, which is thirdeyecss, and you can also call us if you want. Today's topic is comparing different machine learning platforms out there, and in specific, we'll talk about cloud-based machine learning platforms. In this talk, we'll compare 3 online machine learning platforms. We'll compare Amazon machine learning, Azure machine learning, and Databricks cloud. Before we get started though, here's a quick disclaimer about the presentation. Just want to let you guys know that we do work with the vendors, Microsoft, Amazon, and Google, and we've implemented projects with them. But we are not reselling their cloud services, and so we don't get financially awarded by this presentation. This is just meant to be a technical evaluation of the different platforms that we show you today. So a little bit about me. I am a hands-on analytics and data science practitioner. What I help do is I help companies move from the what stage to the why stage and to the what's next stage. So what I mean by that is I help companies start with their PI and analytics projects, and then I help them move along to the analytics maturity curve and help them work on predictive analytics and machine learning projects as well. Along with being a practitioner, I am an active community member. So you can find more about me by visiting my blog, which is insightextractor.com, and I also help run a virtual chapter, and you can find the link to visit the virtual chapter below in the deck. All right. So we have 2 goals for this webinar. One is we want to share a framework with you on how you can evaluate different machine learning platforms. And second, we'll apply that framework to 3 online machine learning platforms. So let's get started. What we are seeing here is a classic knowledge discovery framework. It is pretty common in data mining and machine learning community to use this framework and implement the projects. It has 4 stages. So on the left side of the deck, you can see it has 4 stages, and they are data preparation, data selection, algorithms, and then optimization. So for each of the stages, we'll map out different things that we want to use to evaluate different online machine learning platforms. So in particular, let's look at each of the stages and what are the different evaluation criteria that we have used to evaluate these platforms. So for stage 1, we have data preparation. So on that stage, we'll ask following questions. We'll ask, what are the out-of-the-box support for data sources? In other words, which data can we import to the machine learning platform? We'll also look at the data export capabilities because it's also important for batch predictions, that once you have made your predictions, if you can get the data out of the system. So we'll also look at that. So in short, we'll look at data import and export. Other than that, it's also important that the online machine learning platform tools also help you with things like data cleaning, transformation, and visualization. So why are they important? So data cleaning could be things like you have null values in your records, and those records could then skew your machine learning algorithms that you build, and the predictions could be skewed. So what you want to do is you want a mechanism to deal with them. So it'll be great if the online machine learning platform helps you with data cleaning. So that's just one example. Then there's data transformation. So what could be an example of that? So let's say you have a field in your data set called age, and you want to be able to create age buckets using that field because you want to use that to predict different things from your problem. So data transformation is also important because it helps you create different fields. It helps you transform the data in a way that better predicts what you're looking for. So that's the transformation. And then visualization. As you all know, Can you hear me? Let me unmute everyone and make sure you can hear me, because I got a question that someone can't hear me. Let's see. Just hold on a minute. We'll make sure this is not a technical issue. Okay, it seems you can hear me. What you need to do is, if you can't hear me, you can also dial in using the Join Me platform. There's a way to call in using audio. So just make sure you dial in if you can't hear me. But getting back to the topic, so we're at the data preparation stage where we talked about data import and export. We talked about data cleaning, transformation, and visualization. So we'll use that to evaluate different online machine learning platforms. So that's one stage. Let's move on to the second stage, which is the data selection. Now, this is really important because you want to make sure that out of different data fields that you have after you import your data, that you select the fields that are better predictors that help you build your machine learning algorithm. So this stage is called feature selection and engineering. And at this stage, what you usually do is, out of all the data points that you have, you select the fields that you want to use in your prediction. So very important, it's one of the most overlooked components, and usually it has exponential payoff. So I highly recommend you spend some time on it, and we'll use this as one of the evaluation criteria as well. So that's stage 2. Then stage 3 is the fun part. This is where you apply algorithms and start predicting things that you want to. So some of the things that we'll use to evaluate the online machine learning platforms is, one, which algorithms are supported out of the box. Second, if they're not supported, can you create new algorithms on your own? And maybe there's already an algorithm out there. Can you modify them? So those are some important evaluation criteria for each of those online machine learning platforms. We'll also use this evaluation criteria. Under algorithm stage, there's other important stages where multiple algorithms could help you solve the same problem. So it's very important that you could save the results and compare the results of different algorithms. So you could say which algorithm helps support your evaluation criteria the best. So we'll also evaluate whether the online machine learning platform will help you compare and save results that the different algorithms may give you. So that's stage 3. Stage 4 is optimization. On this stage, what we usually do is, once you have identified the algorithm which is performing the best, you want to further improve it. So some of the things that you can do on this stage, just an example, is you can, most of the algorithms have parameter settings. Sometimes it's also called hyperparameters. So at this stage, you want to tweak the parameters so that the algorithm performs at its optimal level. Now understand that this process is usually not a waterfall process. So it's not stage 1 to stage 4. In many cases, you'll do an iterative process. So you start with data preparation, you select some of the data points, you run your algorithm, you compare results, you optimize it, and then maybe try different things and start from scratch. So note that this is an iterative process as well. So it's an important criteria for online machine learning platforms as well. If it helps you be faster, then that's better. So this is the framework that we'll use moving forward, and the different slides that you'll see now on how we'll evaluate the machine learning platforms. So let's start with first. Let's start with learning about who the contestants are. So in this webinar, we'll look at three online machine learning platforms, and in specific, you'll look at Amazon Machine Learning, we'll look at Microsoft Azure Machine Learning, and we'll also look at Databricks Cloud. And so with that, let's start with one of our first contestants, which is Amazon Machine Learning. Now, Amazon Machine Learning is a part of Amazon Web Services suite. So if you're an Amazon Web Services customer, this is one of the features of the Amazon Web Services Cloud. Also, this service is pretty new. It was relatively recently announced, and we have found that this service is limited in terms of its capabilities and algorithms. Seems like it's the version 1 that AWS put out there for their customers. And our first impression is that it's for existing customers who want to do some basic machine learning investigations. And they also targeted to customers who don't require significant expertise or who might not have a lot of data scientists that data scientists as a part of their team. So it's targeted to those customers. According to the official documentation, you can see that the way Amazon machine learning is targeted, it's targeted for developers of all skill levels, so they're not necessarily targeting the expert developers. Amazon machine learning also provides a wizard. So if you are new to machine learning, you don't have to know the ins and outs. They have a wizard that will take you step by step, and you can create models really easily. But the caveat being that since it's result-based and it's pretty basic, there are a lot of advanced features that are missing. Other things that you can do is once you have your model ready, you could publish an API, and then you can use that API for some of your applications. And the main benefit here is since it's cloud-based, you don't have to worry about the infrastructure. So that's machine learning, Amazon machine learning in a nutshell. Some of the capabilities that the Amazon machine learning provides are as follows. So it provides things like fraud detection, content personalization, document classification, customer churn prediction, marketing campaign analysis, recommendation. So it does cover a lot of use cases. But we'll see that some of the algorithms that it provides are pretty basic. So while it covers a lot of use cases, it just provides two different classes of algorithms. So there's classification algorithms and there are regression algorithms. So let's take a minute to talk about what is classification and what is regression, because it's important for you to know that before we move forward. So for example, let's say you have a problem where you have a data set which is comprised of a few loan applications, and you want to be able to predict which of those loan applications is a high risk or a low risk. So it just has two buckets, high or low. So that is called a binary classification problem, because you just have two class of predictions to be made, which is high risk and low risk. But what if you had multiple classes? What if you had high risk, medium risk, or low risk? So more than two. In that case, that is known as multi-class classification. And problems like this are classified under classification problems. So that's one. The second set of algorithms that Amazon machine learning provides falls under regression. And regression, to give an example of what a predictive problem could look like for regression, imagine that you have a data set that gives you price and discounts. And using that, you want to predict what the sales would look like. So it's a predictive problem where you're predicting a value instead of a class. And usually you apply regression techniques to come up with the predictions. So that's an example of a regression. So while Amazon covers a lot of use cases, their algorithms are classified into two buckets, classification and regression. And note that when you upload the data set to Amazon machine learning, it does not let you pick which algorithm you want to move forward with. So for example, you know that your problem is binary classification, and you upload your data set. Under binary classification, there are a lot of algorithms that could be applied. There's a lot of two-class classification algorithms that you could apply to the problem. But Amazon, by default, uses logistic regression, which is a pretty common two-class classification algorithm, and it doesn't let you change that algorithm. So you can use things like two-class SVM if you wanted. So that's one of the things that you need to know about Amazon machine learning. So I have a screenshot on the deck that says, you have selected the binary attribute to predict, and based on that, we have selected the logistic regression algorithm to do that for you. And maybe let's take that a step further. How would it look like if you open up Amazon machine learning? So you can note that once you have uploaded the data, so on the top part, this is what Amazon machine learning would show you. It'll show you 5 different steps that you need to follow before it gives you the results. And on step 2, when you get to the machine learning model settings, once you have said that this is my problem, I want to predict 2 classes, it'll pick the algorithm logistic regression. And note that there's no settings that says I want to change the algorithm. So that's one of the things that's really important about this platform. And in the introduction, I mentioned that this is a basic version. So this is what I was talking about. While it's great for starting few projects, it's really not great for some advanced needs that you might have. Some of the things that you could do once Amazon Machine Learning has selected the algorithm for you is you can tweak few settings. So for example, you could say what my training and test data set could look like. Pretty simple things, but you can't change the algorithm. So that's something for you to take away as far as Amazon Machine Learning is concerned. So we talked about different algorithms that different predictive problems that Amazon Machine Learning helps you solve, and two kinds of algorithms that it supports. It supports classification and regression. Once you have completed the predictions, you want to make sure that your model is performing against your benchmark. So some of the common industry performance metrics are supported by Amazon Machine Learning. So for binary classification problems, it does help you see binary AUC. So it'll help you see if that matches with what you're expecting, then this is the performance metric that you use to do that for binary classifications problem. It also supports for multi-class classification problems, the F1 score technique. I'll give you that score and you can evaluate whether that's what is acceptable for your problem or for your organization. And if you are working on a regression problem, it helps you see the root mean square error, RMSE, as an abbreviation, and you can see the performance of the regression model. So it does give you those performance metrics that you could use to evaluate the machine learning model that you have built. But again, stepping back, even if it does that, it doesn't let you change the algorithm or do advanced things with the algorithms. So those were some of the low points for Amazon Machine Learning. But where does it really shine? So it really shines when you have your data sets on Amazon Web Services. If you are a customer of Amazon Web Services, Amazon Machine Learning works really well with that existing data storage platform. So if you are on S3 or Redshift, if you have your data sets in there, and if you want to see the viability of creating a machine learning project, then this is a really good use case. It helps you quickly ramp up, and you can create basic models to see if working on a machine learning project and maybe embarking on an advanced project might be good for you. So if you're an existing AWS customer, this is part of the platform. This is one of the features of the platform. So I'll encourage you to play with it and see if it meets some of your needs. So just to conclude, Amazon Machine Learning Platform, we had seen the knowledge discovery framework earlier, so we'll evaluate against it now. So on the data preparation and selection, know that it integrates really well with AWS data sources. So if you have your data on AWS, this is great. Unfortunately, the Wizard and the Amazon Machine Learning Platform doesn't have advanced data cleaning and transformation capabilities, but you can do basic data cleaning and transformations if you want. On the algorithm side, there's limited support. So as we had seen, this supports classification and regression, and under that, it has this selected algorithm for you. So you can't change the algorithm, and you can't add new algorithms or create new algorithms on Amazon Machine Learning. So that way, it's pretty basic. And then on the evaluation and optimizations, it does support helping you evaluate the algorithms using the performance metrics that we saw, but it has limited settings available to tune the algorithm. So you're left with limited choices on how. So if you build a model and if it doesn't meet your performance criteria, then you don't have a lot of settings to play with to tune the algorithm. So that's the conclusion on the Amazon Machine Learning. So now let's move on to the next contestant, which is Microsoft Azure Machine Learning. This is also a cloud-based machine learning platform and was introduced by Microsoft in February of 2015. So while it's relatively young, this is a feature-rich offering. It's part of the Microsoft Azure suite, and also Microsoft recently launched what they call Cortana Analytics Suite. And Azure Machine Learning is one of the tools that they offer along with that. Now, Azure machine learning, unlike Amazon machine learning, has a lot of algorithms that it supports, and it also has a lot of configurations that you can make to do those algorithms. So it's really nice that way. For someone who is new, the Azure machine learning still provides that wizard. It still helps some default algorithms, but then for intermediate and advanced users, you can still tweak those and you can play with different set of algorithms that the platform provides. So it's a really good mix and targeted to both beginners and novice users, as well as intermediate and advanced users. We're also impressed by the usability of Azure ML. They have really nice videos and walkthroughs. So once you get in the environment, it's really easy for someone who has not worked on a machine learning platform to get in there and start building a machine learning project from scratch. So there are a lot of samples. Even if you're not an Azure ML customer, I'll recommend you go through some of the use cases because they have it classified by industry. So you can go there and see if some of those use cases might be applicable for you. So that's a really good thing that Azure ML did for the community. So to take it a step further, I talked about how it's good for beginners and intermediates. And here's how. So for beginners, they have a suggested workflow, so you can follow that. They have this workflow, which is pretty similar to the knowledge discovery framework that I talked about, where you get the data, you process it, you define your features, you select your algorithm, and then you publish it. For intermediate users, if you know what you're doing, they have all the features. Once you get on the machine learning studio, you can see all the options that are out there, which are classified under things like data format conversion, the feature selection, machine learning. So they have really nice integrated development environment that you can go in and start selecting the things that you want and manually start building the machine learning project from scratch if you wanted to. So this is for intermediate users that know what they're doing. So let's quickly go through what the wizard would look like step by step. So when you go on to Azure Machine Learning, you start with selecting your data set, you import the data, and then you start selecting the fields that you will use in your algorithm. So the feature selection stage that we talked about earlier, this is what the screenshot represents. So you start with, when you want to start, you start with all columns, and then you start excluding the ones that you don't want. So that's what's shown in the screenshot. And one of the nice things about this is that the wizard knows the field names and it's data type aware. So for example, it'll know whether a field is an integer or a string. So that will come in really handy if you are doing data transformation. It could also help you with things like data cleaning. So it has different configurations, things like the clean missing data component, which helps you with different things. That you could replace your null values, or you can remove entire rows if you wanted. So it does give you a lot of options on how you want to go and clean your data sets. Once you have built your workflow, this is what it could look like. So notice on the screenshot that you start off with importing the data, which is in this case census income, and then you have you split it into training and test data sets. You train this using a two-class two-step decision tree. You score it and then you evaluate. So as you can see, it's very easy and it's very visual to see what's happening and what's going on inside a project. Once you have ran this, you can see the prediction results. So just like Amazon machine learning, it gives you different performance criteria. So in this case, since it was a binary classification, it gives you this AUC, which is the AUC curve. So you can see that and see if it meets your evaluation criteria. And then it also gives you other things, like it gives you accuracy and precision. So depending on how you want to evaluate all results, you could look at different performance metrics and figure out if this algorithm is performing as per the benchmark that you have set. So very flexible in that terms. Also, workflow entries allow viewing and setting detailed configuration. So each of those algorithms that I talked about has properties with them. So for example, we had two-class boosted decision tree, right? So that algorithm could have a lot of parameters, and you could tune these parameters so that your algorithm performs better. So you can see that once you've selected that algorithm, there are different parameters that you could set. and Azure Machine Learning lets you set those parameters. And each component has its own properties, so you can right-click on them and see whether you want to visualize it or save as a trained model. So each component has it. So as you play with Azure Machine Learning, you'll get to know more about what different options could look like for you. And just so that you know, they also include a lot of useful, popular, and public data sets out of the box. So you could include them in your machine learning project if you wanted to. And you can also, these are really good sample data sets as well that you could play with to create your own machine learning projects. So that's something that's really nice about this. Now, we talked about what the experience could look like for beginners and intermediate users. But there are a few advanced data scientists out there who might want to create their own algorithms and modify those algorithms. So let's take a minute to talk about how they'll do that on Azure Machine Learning. So there's an approach called notebooks approach, which basically means that you open up a web browser and you have an interactive environment where you'll write some code and you'll run the code in the environment. It will tell you, it'll evaluate the code and give you the results of that code. On Azure Machine Learning, under this notebooks approach, you can create a notebook, which is basically, think of it as an interactive environment where you write some code. Azure Machine Learning supports two languages. It supports R and Python code. So if you are familiar with R and Python, you can open this up. You can write quick R code and see what the result could look like. And you could it's really good for testing out different ideas that you might have. So if you don't want to go through the workflow, or if you're doing something really advanced, then you can open up notebooks and start writing your own code. And other good thing about notebooks approach is that if you have existing R or Python code that you have used in your data science projects, then you could take that code and operationalize that code to production using Azure ML as a platform. So Azure ML at that point would become your infrastructure, so you don't have to worry about servers and things like that. Upload your R code on Azure Machine Learning or Python code and get it operationalized. So that's one of the nice things about this platform as well. Some of the algorithms that Azure Machine Learning supports, as you can see, under regression, it gives you different options. So you can pick different algorithms. Under that, for the binary classification, it has few. For multi-class, it has few. For anomaly detection, for clustering. So for each of these categories of algorithms, you get different algorithms that are implemented out of the box. So you don't have to create your own algorithms for this. They're supported out of the box. So you can test out different algorithms and see which algorithm supports your use case the best. So that's really nice about Azure ML. It gives you a lot of choices, and we can test out different things really quickly and see what's going on. They also have a really nice cheat sheet. So if you search for Microsoft Azure Machine Learning cheat sheet, they show you which algorithm is applicable, which basically guides you through which algorithm you should be using for your problem. So for example, if you are working on a two-class classification problem, on the bottom right, you can see that Microsoft lays out different algorithms that they support out of the box. So things like two-class SVM, two-class decision forest, two-class decision jungle. And other thing that I just want you to note that you don't necessarily, if you're a beginner user, you don't necessarily have to know the ins and outs of how these algorithms are implemented. What you can do is you quickly take all of these algorithms and compare them with each other and see which one is performing the best for your use case. So that's something to note. Once you get in intermediate or advanced stage, that you can learn more about how you can set parameters, and if you want to get really advanced, you can start writing your R and Python code and start implementing that as you know. So really good for beginner to advanced users. So we learned a little bit about Azure Machine Learning. I want to conclude this by applying our knowledge discovery framework. So on the data preparation and selection, it does support a number of data sources like SQL database tables, Hive, CSV, OData, etc. Note that Microsoft also has other tools like Azure Data Factory that works really well with Azure Machine Learning. So if there's a data source that Azure Machine Learning does not support, that you could use tools like Azure Data Factory to bring the data in and then import it using Azure Machine Learning. So this is something to note, even though there might not be an out-of-box support for some of the things for Azure Machine Learning, you can use things like Azure Data Factory. There are also some common data cleaning and transformation capabilities included in the studio. So we had seen earlier that I'd show you a few screenshots on how you could create new fields, how you could clean your data set. So that's really nice that some of the basic things are included in the studio. Then on the algorithms, as we had seen, there's a number of algorithms supported. And if you are working a problem where an algorithm that's supported out of the box does not meet the criteria, then you can write your own R or Python code, or you could also extend your existing projects with R and Python code. So that's really nice about Azure Machine Learning. It supports a lot of algorithms for you. Then on the evaluation and optimization, so for each algorithm, it does give you their performance metrics. You can compare results on which algorithm is performing better for you in your use case. And you can also tune the parameters. So we had seen that for each algorithm, you can set the parameters and you can tune them to figure out what might be the best parameter setting for your use case. So that's the conclusion on the Azure Machine Learning. We'll now move on to the last contestant, which is the Databricks cloud. So before we talk about Databricks, let me give you a 1-minute primer on what is Apache Spark and how that is related to Databricks. So Spark is this open source project which has become a de facto standard, just like Hadoop has for distributed computing. And it's rapidly approaching the popularity of Hadoop. And there are different reasons for that. For this webinar, we won't go into the reason why, but Apache Spark, just to set the baseline here, is really popular. It's used by a lot of projects for distributed computing. Now, Databricks is a company that supports the enterprise version of Apache Spark. And they are unique because some of the original creators of Apache Spark are part of that company. And even today, there are a lot of key decision makers in the Apache Spark community that are still associated with Databricks, including the MLLIB library that we'll talk about really soon, which is the machine learning library that Apache Spark supports. So that's why Databricks is one of the leading companies supporting Apache Spark. They have the enterprise version, as I mentioned, and they also have what they call Databricks Cloud, so which is a cloud-based availability of Spark, which also includes things like Spark SQL and Spark Machine Learning, Spark.ml. And if you implement Apache Spark, you'll get other capabilities as well. And also note that Databricks Cloud supports the notebooks approach. So they don't have the wizard and drag and drop approaches that we saw for Azure ML and Amazon Machine Learning, but it does support the notebooks approach. So you can write not just in R and Python, but you can also implement things in Scala and Java if you're familiar with them. So if your existing data scientists have knowledge in those languages, they don't want to learn a new language, they can port their existing skill sets onto Databricks Cloud and start running a machine learning project. Now there are third-party tools that give you the drag and drop approach on top of Apache Spark, but that's out of the scope for this webinar. Will evaluate Databricks Cloud just for what it supports out of the box, which is the notebooks approach. So visually, what does the Spark ecosystem look like? So on the bottom, you have the different core APIs. So as I mentioned, you can create your projects in R, SQL, Python, Scala, or Java. And then on top of it, you can do things like, it supports things like streaming, there's a machine learning library, there's a graph computational framework if you want to do that, there's Spark SQL and data frames. So as you can see, Spark ecosystem is pretty comprehensive. And if you're already on Apache Spark ecosystem, then extending that and using that for machine learning makes perfect sense for you. So let's dive in a little bit and start talking about Databricks Cloud. So this was offered in July 2014 and was announced at the Spark Summit. Let's look at their purpose statement, because usually it tells a lot about who they're targeting and why they want us to use it. So as you can see, they're targeting data scientists and data engineers to focus on experimental and training rather than the infrastructure. So what the value proposition here is that it's for data scientists and data engineers who know what they're doing. So they have R, Python, Scala, Java knowledge, and they take that and they make it really easy for us to focus on building the models rather than things like managing the infrastructure. So that's the core value proposition here. And they conclude by saying that it's a lot more fun if you spend your time on your algorithms and building your models than spending your time on infrastructure, because that's something that we can take care of. So as you can see, they're targeting some of the intermediate and advanced users. So we talked about this. The Databricks cloud approach is the notebooks approach, and you can write your code in R, Python, Java, or Scala. A little bit about notebooks. So notebooks, the way they describe it is they are data scientist friends, because anyone who knows R or Python could just quickly open up a notebook and write some code, evaluate it, and then run it and see in an interactive fashion what's going on, what would be the output of that code. They could also share it with their fellow data scientists, or they share it with the business user as well. So those are some of the things that the notebooks approach provide you. You can experiment with the data, as I talked about. It also supports visualization. So if you want to visualize your data before start building machine learning projects to figure out which data points might be more interesting, you can do that. And then once you have built it, there's a good amount of support available. So you can use things like existing libraries. So for example, R and Python, they're open source as well. So they have a lot of libraries that they support out of the box. So you can rely on those existing libraries and extend your code. So you can just simply use your existing libraries. And if you want, since it's code-based approach, you can also build new algorithms from scratch. So as you can see, it's pretty comprehensive. You could start with using existing libraries to build your machine learning project, and then if that doesn't solve your problems, you can also build new algorithms from scratch. If you open up Databricks Cloud and if you build one of those notebooks, this is what an output could look like. So for example, if you have a linear model, if you display what the results could look like, on the top left, we have an example of that. On top right, there's a k-means model that goes around, and you can see the output of that. And then you can also evaluate your algorithms. On the bottom left, there's a plot that shows you what the false positive rate versus true positive rate looks like. And then you can also write SQL against your data sources to see what the output could look like. So as you can see, you can do a lot of things with the notebooks approach. Get in there, write the code, visualize the data, see what data points make sense for you to use, and start building machine learning machine learning algorithms. And then start evaluating them, comparing them, and then publish them using the Databricks cloud. So it's a pretty end-to-end approach to the data science projects. So to conclude the Databricks cloud, Databricks supports a number of data sources. The notebooks approach lets you build sophisticated data pipelines. So if your data is messy, if it needs a data pipeline, you can build that using the notebooks approach, using the R, SQL, or Python code that I mentioned before. On the algorithm sides, as we have talked about, it supports R, Python, Scala code. So you can write your algorithms on, you can use existing libraries and the algorithms that are already implemented by the open source community. You can leverage them. And if that doesn't work for you, you can definitely create or extend the existing algorithms. And then on evaluation and optimization, you could use different algorithm evaluation metrics. All of them are available. And it also helps, it also supports tuning your parameter settings. So if you have built your project in R, you use an R algorithm and you have all the performance metrics that you can use with that, and we can also tune the parameters because R also gives you that extensibility. So that's the conclusion on the Databricks cloud. And just to wrap up all three, we looked at three different tools. And if you take a look at them, there are three different approaches to this problem. There are point and click solutions. So that is Amazon machine learning and Azure machine learning. In other words, it gives you a wizard that you could follow step by step and build your machine learning platform. Then there's APIs where Amazon machine learning and Azure machine learning helps you do that. So once you have built your model, you can publish the API, and then that could be used by other applications that can call this API and get the predictions. And then there's the notebooks approach. So Azure machine learning and Databricks cloud support that. Amazon machine learning at this point does not. So both of these platforms help you create notebooks, and you can write R or Python code for Azure ML, or R, Python, Scala, or Java code for Databricks cloud. And as a summary for all three platforms, so Amazon machine learning may be good for you if you already have the data in Amazon Web Services, or if you have simpler or fewer options that might be acceptable to you. Azure machine learning from Microsoft is a really strong offering and helps you create good projects, and it's also a really good amount of algorithm that it supports, and it's really good for all the casual and intermediate users. And if you're an advanced user, you can look at the notebooks approach. Then the Databricks cloud is a pretty comprehensive offering. It helps you with a lot of things. It gives you a lot of variety. You can configure the algorithms. It helps the notebooks approach, which means that it has read capabilities. And then it also helps you with options that you can use to tune the infrastructure as well. So if that's what you want to do, you can also do that. So that's the summary on all the three online machine learning platforms. We looked at the framework and the knowledge discovery framework to see what are some of the evaluation criteria for the three platforms, and then we applied them to the three platforms, namely Amazon machine learning, Azure machine learning, and Databricks cloud. And at this point, I'll open it up for any questions that you might have. So to ask your question, please go to info.thirdicss.com/askyourquestion, and as you start submitting the questions on that form, I'll start answering them over here. So again, for those who didn't capture it, it's info.thirdicss.com/askyourquestions. Okay, so I tried opening up the conversation mode, but it seems there's some echo on the line. So I'll probably have to use this form to ask questions, or you could use the chat box as well to ask your questions. The chat box is available on join.me. So while people are submitting their questions, let me quickly open up an Excel document that will use as a giveaway for anyone who asks questions. We have one of our first questions by Devraj. Is Mathematica supported by any of these platforms? That's a good question. So unfortunately, Mathematica is not supported by any of these platforms at this point. But if you have a use case that you can take a use case that you might have with Mathematica and see if you can port those logic over to this platform. So if you're using some underlying algorithms that you implemented using Mathematica, we can take those algorithms and your data sets and see if you could recreate those on Azure machine learning or Amazon machine learning or Databricks cloud. So that's, I think, the best that you can do at this point. But unfortunately, you can't take the algorithms as is on Mathematica and put it on one of these platforms. The other question is, does Azure support distributed training algorithms like those implemented in NLLib, which is basically the spark.nllib? So that's a good question. Maybe stepping back, one of the things that we need to understand is that Azure machine learning runs on an infrastructure. So one of the things that we want to probably do is take a use case that you might have and apply an algorithm to it. And one of the things that you can do that is compare the performance across Azure machine learning or the Spark library that you talked about and see the performance criteria for those two things. Other thing that I can point to is, let me open up the algorithm sheet on the Azure machine learning to give an example of different algorithms that might be supported on Azure machine learning. And you can go through them and figure out if the algorithm that you're looking for and the approach that you're looking for is part of that. So that's what I can suggest at this point. But if you want to get a little bit deeper, I can definitely work with you offline to get you the answer that you're looking for, if that doesn't answer it already. Okay, there's another question. Can you talk about real-life customer scenarios? What machine learning platforms are customers using? Okay, that's a really good question. So there are few things that goes into the selection of the online machine learning platforms in real-world scenarios. So one is if you're already a customer of one of those existing platforms. So for example, AWS is a pretty common tool. So there's a lot of AWS customers. If you already have those data in them, it really makes sense to go for it. And I've seen people using Amazon machine learning to get started. Then I've also seen customers who are existing Microsoft Azure customers. So they'll also, since they're already invested in Microsoft Azure, they'll implement projects in Microsoft Azure and see where it takes them. And then in real world, there are a lot of Spark deployments as well. So for people who are embedded in the Spark ecosystem, it makes really good sense for them to extend it to their machine learning projects. So I've seen all of this online machine learning platform is implemented in real world scenarios. And you can go to each of these platforms and look at some of their customers that they already have to get a sense of where some of this platform might be strong at. But yeah, to answer the question, I've seen most of these platforms being used in real world scenarios. And then the second part of this question was, can you talk about some real life customer scenarios? Sure. So we might not have time to go through each of those platforms and what people are using it in real life, but I'll quickly talk about one of those scenarios that I've seen personally. So for Azure machine learning, I'd seen a really good project where they implemented machine learning algorithm for ad bidding. So in the online advertising world, it's very important that you bid your keywords at the right price. So the algorithm basically predicted the price that might give you the optimal ROI. So it's a really cool project that I had a chance to see, and that's one of the real life customer scenarios that I could talk about. Okay. Is it possible to get the slide for today's presentation? Yes. So the slides will be published, and you should be able to download them. And we'll also send you an email at the end and where you can download the slide. Okay. Other question that we had is, which platform is best for getting help on feature extraction? Okay. So let's step back a little bit. So there's a couple of things that you could do before you put the data in one of these online machine learning platforms. So one, if there is a good feature extraction or selection capability inside the tool, you can definitely use the tool to do that. But if it's not, before putting the data in there, you can have your own data pipeline that does that for you. Now, as far as which platform is best for feature extraction out of the three that we are seeing, I would say Azure machine learning and Databricks, they are good as far as those things are concerned. On Azure machine learning, some of the common capabilities are included, but some of the advanced ones are not. So you're better off creating your own data pipeline before you import the data on Azure machine learning. And then on the Databricks cloud, it depends on your comfort level with R, Python, or Scala or Java, or one of those tools that they support. So if you are really comfortable with building a data pipeline, if you're comfortable with extracting features by writing code and doing that manually, then yeah, you could use Databricks Cloud to build your own pipeline. But that is dependent on knowing those tools and how to go about doing feature extraction using those tools. All right. Okay, so there's a question, one more question. Let me read it out. For cases when data is of a private, secure nature, can't go on an external cloud, but the volume is huge, what would you do? That's a really good question. And so there's two things that you could do here. One, understand that there might be private or secure nature, but if one of those cloud platforms are compliant to those things, then you can use that. So for example, HIPAA is a pretty common thing that comes up. And if one of those cloud providers is compliant, then you could work with them to see if you could put your data on the cloud with those cloud providers. So that's one thing that you could do. You might also have to end up going, they might have some creative solutions for you because they want your business. So that's first thing that you could check. Make sure that even if it's private and secure, if it needs some compliance, that you could work with the cloud service providers to see if it meets. And if it does not, you mentioned if the volume is huge, what would you do? So unfortunately, if it's huge, you can't go to cloud, then you have to build an on-premise platform to do that. Now, when you say volume is huge, I'm assuming you're talking in terms of the modern definition of big data. So in cases like that, you could go with an on-premise deployment of Apache Spark. The Spark is good with dealing with huge amount of data sets. You could read through the different use cases where people might have implemented Apache Spark on premises versus cloud. And there are a lot of companies that have done that. So you can definitely evaluate whether that might be an option that you can do. But if you can't go to cloud, it doesn't give you the compliance or security that you're looking for, then you're left with an on-premise option, and you can deploy one of those distributed computing frameworks, Spark being one of those popular ones, and see if it'll help you with what you need. Okay. There's another question. What benefits do this online machine learning platforms have compared to local ones such as RapidMiner and K9? That's a really good question. So RapidMiner and K9 were really popular tools, and it used even things like SAS, which is used a lot on-premise deployments. So they're really good tools, but one of the challenges that we have is how do you operationalize those algorithms? So usually when you have a local platform, if you want to do predictions, you'll go about manually doing that. So you'll have maybe a CSV or a table that you'll import, you'll run the algorithm manually, and you'll get the output out. You'll have to work around to operationalize them. So usually the challenge there is how do you operationalize some of those algorithms. So for example, let's talk about an online platform like LinkedIn. They have this tool, they have this section called People You May Know, which is basically a recommendation problem. So you can't possibly use a local tool to do something like that. You'll probably have to operationalize some of your data science pipeline. So in cases like that, where you have problems where you want to operationalize, you want the platform to automatically train itself. You just retrain whenever the data changes, or it just gives you the predictions on the fly, so you can publish an API and then run your application against it. So there are a lot of benefits around that. It helps you operationalize some of those things. And second, you don't have to worry about the infrastructure. So if you have a local deployment, then you have to worry about the infrastructure on that. You have to maintain it. You have to make sure it has enough memory, for example, things like that. But if you go to cloud, then those things you don't have to worry about, and you can rely on the cloud service provider to give you that. So two benefits: really easy to operationalize with one of these cloud tools, and then second, you don't have to worry about infrastructure. Okay, there's one more question. Which platform is best for dimension reduction? Okay, so that's a good question. So let me go to Azure Machine Learning. And Azure Machine Learning does help you a little bit with the dimensional reduction capabilities. So there's an out-of-the-box functionality that it does support. Databricks Cloud, if you have built your projects in R or Python, you can do it there. But I guess between which of them is best would depend on your use case and what you're trying to solve. So if you can probably work with us offline, we can help you with what might be the best solution for your use case. It could mean different things for different people. Hope that makes sense. All right. I think we're already at the top of the hour. So I want to thank everyone for attending this webinar. I hope you learned something by going through that framework and learning a little bit more about those 3 platforms. And as always, we are here to help, so feel free to reach out to Third Eye CSS. You have our contact information, so let me show that to you one more time. If you have any further questions, use info.thirdeyecss.com/ask-a-question, and we'll be happy to help you out with any other question that you might have on this. All right. Thanks, everyone. I hope you enjoyed it. Have a good day. Thanks. Bye.